My dear students, let me welcome you all to a new edition of physics. In this edition, we'll learn about the transformer. The transformer is used to step up or down an AC voltage. We'll learn about the structure of the device, its mode of work, its scientific idea. So let's get started. The transformer. What about the transformer? It is a device. A transformer is a device that transforms an AC voltage. It should be an AC, alternating current voltage, from one value to another. So once again, it is a device that it changes an AC voltage from one value to another. It steps up or down an AC voltage. Okay, it steps up or down an AC voltage. And what about the idea of the transformer? We want the scientific idea of the transformer. Is it based on self-induction, mutual induction, or whatever? Okay, of course, it is based on mutual induction. So scientific idea of the transformer is mutual induction. And talking about the structure of the device. In front of you, we've got a figure that shows the structure of the device. So we have three major main components. Okay. First of all, an iron core, and it is laminated as shown in front of you. So we've got an iron core and primary coil connected to the mains, and secondary coil connected to the device we want to change the potential for it. Okay, so the three major components of the transformer are primary coil, secondary coil, and the two coils are wound on a core made of soft iron and should be laminated. What about mode of work of the transformer? So talking about mode of work of the transformer, when an AC voltage is connected to the primary coil, so the primary coil is connected to the mains. When an AC voltage is connected to the primary coil, an AC current flows in the primary coil. This current produces a changing magnetic field, which induces an EMF. So an EMF is induced in the primary coil. And as a matter of fact, an EMF is induced in the secondary coil also. So an EMF is induced in both the primary and secondary coils. If we assume that there is no leakage of flux, that's to say, all the flux lines produced by the primary coil, links the secondary, and the coils have negligible resistance, we can say from Faraday's laws, EMF induced in the primary, okay, it is denoted by Vp, it is equal to minus Np delta phi magnetic over delta T. Yes, this is Faraday's law. EMF induced in the primary is equal to the number of turns of this coil, number of turns of the primary coil, times rate of change of the magnetic flux through this coil. Also, EMF induced in the secondary coil, denoted by Vs, is equal to number of turns on the secondary and S, and rate of change, same rate of change. We assumed it is 100% efficient. Okay, by division we can say from 1 and 2, we can say Vp over Vs is equal to Np over Ns. That's to say we've got, yes, a direct relation between the EMF induced and the number of turns on the coil. V is directly proportional to the number of turns. Vp over Vs is equal to Np over Ns. And let me remind you with something. This to be used only when the transformer is assumed to be 100% efficient. Okay? So when the number of turns of the secondary coil is greater than that on the primary coil. Now we want to know how to obtain a step up or a step down. It has to do with the number of turns. When the number of turns of the secondary coil is the output coil. If the number of turns is greater than the number of turns of the primary. So the output voltage is greater than the input voltage, and that transformer is a step-up transformer. So we'll obtain a step-up transformer when the number of turns on the secondary coil is greater than the turns on the primary coil. When the number of turns of the primary is greater than that of the secondary, what happens? The output voltage is less than the input voltage, and the transformer is a step-down transformer. So when N primary is greater than N secondary, V primary will be greater than V secondary, and the device is a step-down transformer. And now talking about the relation between voltage and current in a transformer. Okay. Like any other device, the transformer obeys the principle of conservation of energy. Energy formula that gives energy is VIT, V-I-T. Power is V-I, okay? So it obeys the conservation of energy. So we can say VP-IP, the input power, is equal to the output power, VS-IS. So we can say Vp over Vs is equal to Is over Ip. So we've got an inverse relation between current and voltage. And this means a device which is a step up for the voltage will be a step down for the current. Okay? So since Vp over Vs is equal to Np over Ns, it is equal to, yes, Np over Ns. So we can say it is equal to Is over Ip. And now we've got something very important to mention. Transformers, as I said, therefore transform current as well as voltage. Transformers, it change current and voltage. And a step-up transformer for voltage will be a step-down transformer for current. And vice versa. This means, for example, that a transformer which reduces voltage will increase current in the same proportion, so that the power remains the same. And now let's make a comparison between step-up transformer and step-down transformer. First of all, first point of difference is the number of turns found on primary and secondary coil. Number of turns on the secondary is greater than that on the primary in the step-up transformer. But it is the opposite, talking about a step-down transformer. Np will be greater than Ns. And we've got a direct proportion between voltage and turns. So we expect that Vs will be greater than Vp in a step-up transformer, but Vp will be greater than Vs in a step-down transformer. And we've got an inverse relation between current and voltage in a transformer. So in a step-up transformer where the voltage is increased, the current is decreased. It means Ip will be greater than Is. Current through the primary is greater than the current of the secondary, and it is greater in the secondary. Yes, current of the secondary coil will be greater than the current of the primary in a step-down transformer. And now talking about efficiency of a transformer. In practice, there is no 100% efficient transformer. And the question is why? Why there is no 100% efficient transformer? It means there is a loss of electric energy. There is a loss of electric power in any transformer. And now talking about causes of energy losses in the transformer. Okay, and in this way we are answering very important question, very important give reason why there is no 100% efficient transformer. Okay, talking about causes of energy losses in the transformer. First of all, some of the electrical energy supplied to the primary coil, some of electric energy is lost as thermal energy, is lost in form of heat because of the ohmic resistance of the coils. Okay, because of the ohmic resistance of the coils. The coils give off heat when current flows through them. Okay. And how to reduce? We cannot eliminate this, but we can reduce it. How to reduce this loss? Okay, coil resistance is kept as low as possible by making the coils from thick copper wires. So the coils should be made of copper. Why? Because it has low resistance. To reduce the loss of power in form of heat. Okay, this is one, yes, one loss. Also, some of the electric energy supplied to the primary coil is lost as thermal energy, but due to another different reason is lost in form of thermal energy because of eddy currents produced in the core. These currents are induced in the core. Why? Because the core itself is subject to changing magnetic field. So eddy currents are induced in the core because the core itself is a conductor in a changing magnetic field. And how to minimize this loss, how to minimize the loss in power in form of heat because of eddy currents. Okay, the core is made of laminations, is made of sheets of siliconic soft iron, and they should be insulated from each other. Okay, so once again, the core is made of laminations. Is made of sheets of siliconic soft iron insulated from each other so that their total resistance is high. The induced currents in the core cannot flow across the insulation from one sheet to another, from sheet to the next. And so the loss of energy, the loss of electric energy as heat is considerably reduced. Also, another conversion here, part of electric energy is converted into mechanical energy. Part of electric energy is converted into mechanical energy consumed in moving the magnetic molecules of the core, in magnetizing the core. Okay, the core is made from siliconic soft iron, which magnetizes and demagnetizes easily to reduce this, yes, loss of power. Okay, and finally, part of the electric energy is lost as a magnetic leakage. Part is lost as a magnetic leakage. As a matter of fact, not all the flux lines produced by the primary coil, yes, link the secondary coil. To reduce this leakage, the secondary coil is wound around the top of the primary. To reduce this leakage, the secondary coil is wound on the top of the primary. Efficiency of the transformer is given from the output power over input power. Also, we can say output energy over input energy. It is the same. So efficiency is equal to VSIS over VPIP. And we can say it is VSNP over VPNS. And now, talking about high voltage transmission of electric power. Talking about high voltage transmission of electric power. We've got very important to give reason here. A step-up transformer is used in power stations to step up the voltage before transmitting the generated electric energy in cables. Why? We'll try to explain this. When the voltage is stepped up, what happens to the current? The current is stepped down. Thus, the loss of power, loss of the electric power as heat in form of heat, which is given by the expression I squared R, is much reduced, much decreased. Since we decrease the current and the current in the... My dear students, let me welcome you all to a new edition of physics. In this edition, we'll learn about the transformer. The transformer is used to step up or down an AC voltage. We'll learn about the structure of the device, its mode of work, its scientific idea. So let's get started. The transformer. What about the transformer? It is a device. A transformer is a device that it changes, that transforms an AC voltage. It should be an AC, alternating current voltage, from one value to another. So once again, it is a device that it changes an AC voltage from... My dear students, let me welcome efficient. So we can say VSIS is equal to VPIP. So Vs over Vp is equal to Ip over Is. We've got an inverse relation. So when the voltage is increased, the current is decreased. Another give reason, in the transformer, the wires of the primary and secondary windings are made of copper. Because copper has very, a small ohmic resistance. So the amount of electric energy lost in the form of heat is reduced. Once again, copper has very small ohmic resistance. So the amount of electric energy lost in the form of heat is much reduced. Another give reason, in the transformer, the secondary coil is wrapped around the primary coil. In the transformer, the secondary coil is wrapped around the primary coil. The secondary coil is wrapped around the primary coil to decrease the leakage of the magnetic flux. Another give reason, in the transformer, soft iron core rather than steel is used. Soft iron and not steel is used. Okay. Soft iron is more easily magnetized than steel and loses its magnetization easily. And loses its magnetism more easily, so the work done in magnetizing and demagnetizing the core is reduced. That is to say, the loss in electric energy in the form of mechanical energy is reduced. Another give reason, the core of the transformer is laminated. The core is made up of strips, laminations, made up of laminations. Why? Each is insulated from one another to reduce the eddy currents by increasing the resistance. Another give reason, the transformer works only if it is connected to an AC supply. Let me say it again. The transformer works only if it is connected to an AC supply. It means it doesn't work on DC supply. Why? The transformer is based on mutual induction, and mutual induction requires a changing magnetic field to be produced. So let me say it again. The transformer is based on mutual induction, which requires a changing magnetic field to be produced. And what about direct current? But direct current has a steady magnetic field. So the transformer does not work if it is connected to a DC supply, because it needs a changing magnetic field as it is based on mutual induction. We've got a problem here, a transformer with 1100 turn on primary. Okay, a transformer with 1100 turn primary has two secondary windings, has two secondary coils. One secondary is connected to 6 volt 0.4 ampere, 6 volt 0.6 ampere lamp. The other secondary is connected to 12 volt 0.35 ampere lamp. If the primary is connected to 220 volt source and the transformer is 75% efficient, calculate the number of turns on each secondary windings, the intensity of the current flowing in the primary circuit. Okay, efficiency is 75% efficient. Okay, so 75 over 100 equals Vs1 NP over Vp NS1. So 75 over 100 is equal to 6 times 1100 over 220 times NS1. In this case, we managed to obtain the number of turns on the first secondary. NS1 is 40 turns. We'll do the same concerning the other secondary. So 75 over 100 is equal to Vs2 and P over Vp and S2. Okay, so 75 over 100 equals 12 times 1100 over 220 times NS2, and this way we managed to obtain the number of turns on the other secondary. It is 80 turns. It is 75% efficient, so 0.75 times the input power will be equal to the produced power. Okay, in the problem, efficiency is mentioned to be equal to 0.75. So 0.75 of the input voltage will be the produced. So 0.75 of the input power will be the produced power. So we can say 0.75 times 220 IP is equal to produced power in the two coils, 0.4 times 6 plus 12 times 0.35. In this way we managed to obtain IP. It is equal to 0.04 ampere. And this way we've come to the end of this edition. Until we meet again, my best wishes to you all. My dear students, let me welcome you all to a new edition of physics. In this edition we'll learn about the transformer. The transformer is used to step up or down an AC voltage. We'll learn about the structure of the device, its mode of work, its scientific idea. So let's get started. The transformer. What about the transformer? It is a device. A transformer is a device that transforms an AC voltage. It should be an AC, alternating current voltage,